Hello students, this lesson is over compound interest and using functions involving a constant that we call e. E is an irrational number, and you're going to see what that number is in this lesson. Okay, so first we're going to look at a compound interest formula, and this is used except for when it says compounded continuously. Okay. When the bank pays interest on both the principal and the interest an account has already earned, the bank is paying compound interest. The compound interest formula for the amount A in an account compounded at specific intervals, except for continuous compounding. If it says that it is continuously compounded, then we're going to use a different formula. It is given below. So here's the formula, and this should look familiar to a formula that we used when we were talking about exponential growth and decay. The difference is that it could be compounded. It can be compounded quarterly. It can be compounded daily, monthly. There are many different intervals that interest can be compounded, and so this is the general formula that you can use for all of the different situations. Okay, here is what the variables stand for. A is the ending value. Okay, P is the principal, which is considered the initial value. R is your interest rate expressed as a decimal. So, if it was 10% interest, you would need to convert that to a decimal, so you would use 0.10. N is the number of times that interest is calculated per year. So if it's quarterly, then it's compounded 4 times a year. If it's compounded monthly, then that would be 12 times a year. So you have to pay attention to how many times it's compounded so that you can get the correct number in for N. And then T is the time in years. Okay. We're going to use our calculator to explore what happens when $1,000 is invested at a rate of 10% for 1 year and the interest is compounded more and more frequently. So let's see what difference it makes when it is compounded annually, which would be just 1 time a year, semi-annually, which means twice a year, quarterly is 4 times a year, monthly is 12 times a year, daily would be 365 days a year, or times a year, and then hourly, and then minute. And we're just going to see what happens to the value. So if you look at the first one, and I'm not really sure why this came out as 1G. That's supposed to be 1 times 1. So if you look at what happens annually, if it was compounded annually, we would plug in, first of all, it's 10%, so we're going to plug in a 0.1 for our rate. So you can see that I did that right here. Okay, and then if it's just compounded annually, that would be 1 time per year. So for N, we're going to plug in the 1 here and here. Okay, and then T, of course, is just going to stay 1. So if we plug that into our calculator, we'll see that at the end of that first year, we will have a value of $1,100. Okay? Well, let's see how that increases when we change it to semi-annually. Semi-annually means that it happens twice a year. So for N, we're going to put in a 2 here and here. And again, that G is supposed to be a times 1. We're using the same rate, so take a minute and plug that into your calculator. And you'll see that that comes out to be $1,102.50. Okay. Take a few minutes and fill out the rest of this table. Of course, quarterly you're going to be plugging in a 4 for N. And then monthly would be 12 for N, and so on and so forth. So take a few minutes and fill out the rest of this table. Okay, so this is what you should have gotten as you started to fill in the table. As you can see that as the time goes by, it starts to level out a little bit. So let's look at a couple of practice problems. In example 1, Ben deposited $500 in his savings account. The account pays interest at 7% compounded quarterly. So I'm going to underline that. How much money will Ben have in 3 years? So let's start to label what the variables are in our equation. So A is going to be the after amount, which I don't know that yet. P is the original amount, which is $500. R is the interest rate. Well, if it's at 7%, if I convert that to a decimal, I have to move the decimal over twice. So that would be 0.07. So that's going to be my rate. The N, it's compounded quarterly, so that means it's compounded 4 times a year. So that's going to be a 4. And then T, how much money will Ben have in 3 years? So we're going to figure it out after 3 years, so our T is going to be 3. Okay? So let's go ahead and set up what the equation is. Here's our equation. It's A equals P parentheses 1 plus R over N, and then raised to the NT power. Okay, so we're going to go ahead and plug in our numbers. P is 500. 1 plus the rate is 0.07 divided by N, which is 4, raised up to the NT, so 4 times the T, which is 3. Okay, so pause the video and let's go ahead and enter that into your calculator to see what A is. Okay, so after plugging that into your calculator, you should have gotten that the money after 3 years would be $615.72. And of course, we're going to round to the nearest hundredth because that's what the cents would be. Okay, in this next problem, example 2, how much would you have to invest to have $20,000 after 6 years in an account earning 8.5% interest that is compounded monthly? So one thing I want you to notice about this problem is it says how much would you have to invest to have $20,000. So $20,000 is not what you're investing. That's what you're going to have after 6 years. Okay, so that's going to be your A. And then P is what we're trying to find. That's what we want to know, how much would you invest initially. And then our R is going to be our interest rate, 8.5%. If I move that over twice, that's going to be 0.085. N compounded monthly, that would mean that my N is 12. And then T is after 6 years, so that's going to be 6. Okay, so let's go ahead and get our equation set up. It would be $20,000 equals P is what we're going to try to find, so I'm going to call that P. And then we have 1 plus 0.085 divided by 12. And then we're going to raise that up to the NT, which would be 12 times 6. And that's going to be our exponent. Okay, so since we're trying to find P, we need to get P by itself, which means we need to figure out what this amount is. So go ahead and type that into your calculator. So I'm going to put 20,000 equals P, and now we're going to type this into our calculator and see what this is. Okay, so after typing that into the calculator, I get that this is 1.6623, And we're going to go ahead and leave that into our calculator, but remember we're going to divide by that, because if we're going to get p by itself, we're going to have to divide by that whole number. Try and keep it into your calculator so that you're not having to round it, which is going to affect your answer. And let's go ahead and figure out what that is on our calculator. So 2,000 divided by, you can do second negative sign to get the previous answer, and then hit enter. And so it looks like the original amount that I need to invest says 1,200. Whoops, I just realized I typed that in wrong. Hold on just one moment. Okay, I had forgotten to put 20,000. I just put 2,000. So it shouldn't be 1,200. It's going to be 12,031, and I have 52 cents. Okay, so that is the original amount that I need to invest. Okay, so let's see what this number E is about. I want you to use a calculator to help you complete the following table. So take a few minutes, pause the video, and go ahead and type this in on your calculator. You're going to use these values for n. So in this first problem, we're going to take, or first number, we're going to take 1 plus 1 divided by 10, and we're going to raise it up to the 10th power. So we're just taking those values and we're plugging them in for n. So pause the video and do that, and then come back. Okay, these are the numbers that you got as you plugged in those values for n. So as you can see that as n continues to increase, the numbers get closer and closer together. They're going to level out at a certain number. So you can write that in for that question. It says, and then find the key labeled E on your calculator and record the value of E. So look on your calculator and you'll see that it's right above the division sign. If you hit second division, then it'll put an E on your calculator, and if you just hit enter, this is the number that you should get. You should get 2.718281, and then 828. So you can see that this number is very similar to this last number that we got in our table. How's this value compare with the last value in the table? Well, it's very close to it. It's not that far away from it. So what you'll see is that we have this value E. It is an irrational number, and this is how we got it, is from using this table. We see that these values are going to get closer and closer to this number. So this is a limit for this for compounded interest. So when you're working with this value E, when we simplify it, we look at it just like what we would a variable. In these problems right here, simplify expressions containing the number E, it says write the exact answers and do not use your calculator. Okay, in this first problem, again, that G is not supposed to be there. It's supposed to be a times symbol. So that should be E squared times E to the 5th. Well, we're not going to use our calculator to get a value for E. We just know that we're using that symbol E to represent that number. So if you take E squared times E to the 5th, remember you're multiplying exponentially, which means that you add those exponents together. So that would just be E to the 7th. Okay? Let's look at number 2. 12E to the 4th divided by 3E to the 3rd. Well, you take the numbers and you divide them. So 12 divided by 3 is just 4. And then E to the 4th divided by E to the 3rd, remember you subtract them. You subtract the exponents, so that would just be E. So the answer would be 4E. Okay. Number 3, we have something being raised to the power of 2. Remember that power of 2 is going to go to the 5, and it's also going to go to the e to the negative 3x. So we have 5 squared, which is going to give us 25. And then we have e to the negative 3x getting raised to the power of 2. So remember, whenever you have a power to a power, you multiply them. So that would be e to the negative 6x. And when you have a negative power, that flips it. So this would be the same thing as 25 on top divided by e to the 6x, because we're flipping that e down to the bottom. Okay. All right, so when are you going to use the value e? Well, right now it is used when we have a compounded continuously problem. Compounded continuously means that it's just continuously compounded throughout the year. So when you do that, we have a different formula, and I call it the PERT formula because it spells out PERT. But it's A equals P times e to the RT formula, and this all comes from that table that I just did on the previous page. The values are getting closer and closer to this value e, so that's what we just end up using when we have a compounded continuously problem. Alright, so let's look and see an example of how we're going to do this. Terry deposited $100 he got for his 5th birthday in a savings account that compounds continuously at 5%. Today is his 21st birthday, and he wants to withdraw the money. How much does he have? Well, originally he invested $100, so that's going to be your P. The rate is 5%, so we're going to put in a 0.05 for that. And then T is the time. Well, if he got it for his 5th birthday and he is turning 21, then the T would be 21 minus 5, which is 16 years later. Okay, so let's use our formula. We have A equals P times e to the RT. So P is 100. And then we've got e to the r, which is 0.05, times t, which is 16. Okay, so type that in on your calculator. And after plugging it into the calculator, I got $222.55. Alright, so this next problem, suppose you invest $1,500 at an annual interest rate of 9.5% compounded continuously. How much will you have in the account after 5 years? And then how much will you have in the account after 25 years? Okay, so we've got two values. We're going to have two separate problems. If we invested $1,500, that initial amount is going to be the same in both cases. And an annual interest rate of 9.5%, so we're going to move that over twice, so that would be 0.095. And then time, in our first example, it's going to be 5 years, and then we're also going to do in 25 years. So here's what we have. We have A equals P, which is 1,500, times e to the r, which is 0.095, and in our first example the t is 5, and so we're going to type this into the calculator. 1,500 second division times e, raise it up to the 0.095, parentheses 5, enter. So it looks like after 5 years they will have $2,412.02. And then after 25 years, let's figure out what that would be. 1,500 times e to the 0.095 times 25. Let me type that into the calculator really quick. And that is going to be $16,126.52. So you can see that compounded continuously, it increases a little bit more faster, and after 25 years, that's a pretty good amount. Okay, so for this next example, I want you to write this down. Let's say that you want to have $10,000 and you're going to originally invest $1,000 at 7% interest that is compounded continuously. Okay? And you want to know how many years is that going to take for you to get the $10,000. Well, you know you're going to use the formula A equals P times E to the RT. Okay, but here's what's a little different in this problem. If we plug in these numbers, we have $10,000. We invested $1,000. We have E, the R is 0.07 because it was 7%. And then we have T, which we don't know, so we're going to put a T there. Okay? Well, you're going to have to be able to get up into this exponent. So the very first thing you're going to do is you're going to divide by 1,000 on both sides. Okay? Well, that gives you 10 over here, and that's equal to E to the 0.07t. Okay? Well, how do you get up to the exponent? Well, when your unknown is in the exponent, you have to convert it to a logarithm. But here's the problem. Our base is e. Now, you don't know what kind of logarithm has a base e, but I'm going to tell you it's called a natural log. Okay? So when you have a log, when you have a log that has base e, that is called a natural log. The abbreviation for that is LN. So you see a button on your calculator, it says LN. That is when you're using the natural log. So if I convert this to an exponent, I'm going to start with my base, and I'm going to swirl around. It's going to be equal like this. So I've got the natural log because it has base e, so I'm going to put ln of 10, and that equals my exponent, which is 0.07t. Well, now I can do ln of 10, the natural log of 10, on my calculator, and I get approximately 2.3025, but I'm going to store that into my calculator. It's equal to 0.07t. So in order to get t by itself, I'm going to have to divide by 0.07 on both sides. So do that on your calculator. And for t, we get about 32.89 years. So at the end of 32 years, I don't have 10,000. So I would go ahead and round that up and say it's going to take approximately 33 years. Okay? So I want you to keep in mind that when you're trying to solve for an exponent, you have to convert it to a log. If the base is e, then we use the natural log. Okay? If the base is something else, then we'll use just the regular log. Okay? So keep that in mind. Natural log, they follow the same properties as regular logs. So the multiplication property, division property, power property, all of that is the same. So I'll talk to you more about this tomorrow when we are working on the review. Okay? So you've got a worksheet to work on for this assignment, and I will help you more on it tomorrow if needed.